In this video, we're going to talk about regression on the TI84 and using the Desmos app. You remember regression was finding the equation of our line of best fit for scatter plots. Or instead of having to calculate them by hand, we could do it by calculator. And we had a little thing to determine how good the regressions were. The first one was called R, and that was our correlation coefficient. And what the correlation coefficient used to tell us, it was always a value between 0 and 1. And the closer to 1 it was, the better the regression was, or negative. The more the data fit the line. And then we moved into quadratics, and we end up with something called the coefficient of determination. And the coefficient of determination is the same type of thing as the correlation coefficient. It's still going to be between 0 and 1. And it actually discusses the variance and how much the variables actually deviate from the lines. It's basically the same thing, but not exactly if we get into precise statistics. But the closer it is to 1, the better match it is. So we're going to learn how to do this on both the TI84 and the Desmos calculator. So we're going to use this data for both of them, just so we can show that we're doing the same thing for both. And I think first, let's go ahead and use the TI calculator. I'm going to go through at this point some things on the calculator that I like to do or that you have to do, just because I'm not sure that we all have the same level. First thing I always like to do, if I'm picking up a calculator that's not mine, meaning I picked one up from the back closet or whatever, I always reset it because I don't know what crazy things people have done to it. They've changed the window size, they've changed the variables, it doesn't matter. So second plus 7, enter 2. And what that does is it resets it back to your factory defaults. So it gets rid of any personalized settings that somebody may have done. So that's the first thing you're always going to want to do, and this resets your history, or it resets everything. The second thing you have to do is go second, 0, which is catalog, and go down until you find diagnostic on. So I'm going to go down until I find diagnostic on. And I'm going to hit enter. And I'm going to hit enter. And it'll say done. What this has done is turn on statistical diagnostics. So we're going to get our R value when we do the regression. So now my calculator is set up. Let's go ahead and put our data in. So we're going to hit stat and edit. I'm going to put the X values in L1. So our X value is 1358649. 1358649. And our Y values 14, 12, 13, 14, 12, 13. Oops. 14, 12, 13, 6, 9, 11, 2. 6, 9, 11, 2. Make sure your data is right, because as you saw, I had a hard time plugging in 12 there for some reason. It didn't want to take. I had to make sure it's right, or else your data is going to be totally wrong. So that's the part where we've now entered the data. Now we're going to do linear regression. And the way that we do that is we go into the stat menu, we go over to calc, and we're going to go down to linreg ax plus b. and it defaults to L1's the X, L2's the Y, which is fine. And we're going to go down and hit calculate. And what it's done is it's given us the equation of the line of best fit. Y equals negative 1.399x plus 16.768. It says that the correlation coefficient is negative 0.914, pretty decent, pretty close to 1. And the coefficient of determination, the R squared, is 0.836. Still pretty good. So this tells us that we have a pretty decent model for the data. If you wanted to view the data, if you just hit graph, you're not going to see anything. First thing you're going to have to do is go in and turn on stat plot. So second, y equals, gives you stat plot, turn on stat plot 1. And now we'll start to see some points. I need to change my window. I'll change my window. I'll go from -1 to 15. And then we'll just say -1 to 15. So I don't know how many values are greater than 15. Now if I hit graph, I see all of my points displayed on the graph. And if I go back into that stat and calc and linreg, I can actually go in here and tell it to store this equation. And the way I do that is I hit vars, go over to yvars, function, y1. So what it's going to do is it's going to calculate the regression, and then it's going to store it in y1 in my graphs. Now if I hit graph, it'll also draw my line of best fit. So if you look at y equals, hey look, there's our equation that we just calculated. And if we go to graph, it shows our line of best fit. Now, linear regression is only one of the types of regression that we do. Another one that we like to do is quadratic regression. It's there under quadreg. So I'm going to go back into stat, calc, quadreg, and I'm going to store this one in y2. So I'm going to go to vars, yvars, function, and put it in 2 and calculate. Now, if I look at my values, it gives me the A, B, and C that I can plug into the function, but this R squared is 0.9295. If you remember our R squared back on the linear regression, it was only 0.8363. So what that's saying is that since the quadratic regression has an R squared value closer to 1 at 0.9295, the quadratic regression is actually a better model than the linear. If I hit graph, it'll show both of them, and we can kind of see that the quadratic regression, that it curves up and comes back down, is closer to a lot of the points. So that's graphing regressions on TI. Now, let's go ahead and switch over to Desmos. If you don't have a calculator at home, you can use Desmos. Desmos is a fantastic graphing calculator. It's going to do the same thing. Just a couple things that are a little quirky with regression, why I want to go through it. I'm going to click, so I went to desmos.com. This is how it shows up. Don't have to sign in or anything, just hit graphing calculator. Now, if you wanted to save it, you'd have to sign in. Now, I want to put in my data. So I'm going to hit plus, and I want to create a table. And it says X values and Y values. So I'm going to go back to this. My X values, 1, 3, 5, 1, 3, 5, 8, 6, 4, 9, 6, 4, 9. And then my y values, 14, 12, 13, 6, 9, 11, and 2. All right. Now, I look over here, I can only see like this 1 point. Well, it's because my window's the wrong size. You can do two things. First thing you could do would just be to drag it over and resize it that way. If you want a little better way to do it, you can hit this little guy right here. That is your graph settings. And I can say, hey, go from -1 to 0 to 15, -1 to 15. Close that up. And there's my graph. And it looks the same as my graph that I had in TI. Now, here's the little tricky part. If I want to find the regression, there's a specific way you have to do this, which is why I'm making a video. You'll see that this is Y1, this is X1. So to type in a regression, I'm going to have to do Y1. And then I'm going to use the tilde, the little symbol in the top left corner of your keyboard. You have to hit shift to get it, of course. And then I want linear, so I'm going to say M times X1 plus B. And what it's going to do is it's going to calculate M and B. It's going to tell you that M is about that, B is about that, and here's the correlation coefficient and the coefficient of determination, 0.8364. Well, if I go back to my TI, under linear regression, I had 0.8364. So it's going to give me the same value. So now I'm going to go ahead and put in the quadratic regression. I'm going to do Y1 and the tilde. Now I need 3 variables to throw in front of my x squared, my x, and my constant term. I'm going to choose any 3. You can't choose I, you can't choose E. I already used M and B, so let's go P of x1 squared plus R of x1 plus Q. And it gives me my quadratic regression. Hey, that's the same regression that we got using the TI calculator, which is what we expected. And we can see, the thing I like about the Desmos one is I still have my linear one here and my quadratic. I can see both their regressions on here, and I can see that, hey, this is a better model. And if I go ahead and I click on that, I can actually turn off the function that's not as good. So I'm just looking at the one that's good. All right. So I kind of like the Desmos one. I like it enough that I'm not going to do that then. So that should give you an overview on how to do regressions. If you have questions, of course, you can ask me.